Hello everyone, I am Dr. Godan Raman, Mathematics Professor. Today we are going to discuss with single server with infinite capacity problem. This model represents a queuing system with a single server, Poisson arrival, exponential service time, and there is no limit on the system capacity, and the customers are served on the basis of first come first service. First of all, I will give the formula. It will help to solving the following problem. We consider lambda arrival rate 1 by lambda inter arrival rate, mu service rate 1 by mu exponential with the mean service rate, P naught probability that the system is empty, it's equal to 1 minus lambda by mu, probability of n customer in the system Pn, it's equal to lambda by mu whole power n into P naught, probability that the system is busy 1 minus P naught, it's equal to lambda divided by mu, expected number of customer in the system Ls, it's equal to lambda by mu minus lambda. Expected number of customer in the queue LQ, it's equal to lambda square divided by mu into mu minus lambda. Expected number of customer in non-empty queue Ln is equal to mu divided by mu minus lambda. Expected waiting time a customer in the system Ws is equal to 1 divided by mu minus lambda. Average waiting time that a customer in the queue WQ is equal to lambda divided by mu into mu minus lambda. Next, little formula. One of the most powerful relationship in queuing theory was developed by John D.C. Little. He related the steady state mean system size to the average waiting time. If the random variable representing time spent in the system, time spent in the queue and service time, then little formulas are Ls equal to lambda Ws, LQ equal to lambda WQ, Ws equal to WQ plus 1 by mu, Ls equal to LQ plus lambda by mu. Now we are going to discuss with the problem. Customers arrive at a watch repair shop according to Poisson process at a rate of 1 per every 10 minutes and the service time is exponential random variable with the mean 8 minutes. First question, find the average number of customer in the shop. Second one, find the average time customer spend in the shop. Third one, find the average number of customer in the queue. And the fourth one, what is the probability that the server is idle. Before starting the problem, first check the given model because we have to discuss with what is the model. MM1 infinity first come first serve. This is the first model, is nothing but single server infinite capacity. Then another model single server finite capacity. Then another model multiple server infinite capacity. Then multiple server finite capacity. Therefore, first of all you check the server is single server or multiple server. Whenever looking the problem, so the specific look at here the customer and server. So here the server is single because nothing to mention here more number of server provided service. Therefore here consider single server. And then to check with the capacity value, here the capacity value is not mentioned, therefore we consider it's an infinite number of capacity. Once you identified the model, this model is single server infinite capacity. Once you finalized the model, then you just write whatever given the value. Now arrival rate, I'll take the lambda is our arrival rate, so 1 per every 10 minutes. So you continue with minutes or to convert minutes into hours. Now I am going to convert minutes to hours. Therefore 1 every 10 minutes, 1 by 10 minutes to convert into hours, multiply with the 60. Therefore 6 per hour the lambda value. Then exponential random variable with the mean. So exponential random variable with the mean, its meaning it's 1 by mu. The value is 8 minutes. I just converted the minutes into the hours. Therefore mu equal to 1 by 8 minutes and then multiply with the 60. Then it's converted to hours, 15 by 2 hours. Then the first question, average number of customer in the shop. That's the meaning the queuing theory answered two questions. One is number of customer and waiting time. Number of customer in the system, number of customer in the queue, and then waiting time in the system, waiting time in the queue. Therefore, the first question, average number of customer in the shop. Shop is the system. Therefore, to calculate LS. LS is the formula lambda divided by mu minus lambda. Now we know the value of lambda. Just substitute lambda and mu value for this formula. Lambda is 6, mu 15 by 2, then the value 4 customers per hour. Then the second question, average time customer spend in the shop. So average time means waiting time. So the customer waiting time where in the system, the WS. The formula for WS to calculate here 1 divided by mu minus lambda. Substitute mu lambda value, then the WS is nothing but 2 by 3 per hour. Then the next question, average number of customer in the queue. So number of customer, I mentioned here number is nothing but L. Therefore number of customer in the queue, LQ, to calculate lambda square divided by mu into mu minus lambda. So substitute lambda value, mu value, lambda 6, mu 15 by 2. Therefore LQ value 16 divided by 5. What is the probability that the server is idle? Server is idle is nothing but probability of 0 customer. It's a P naught. 1 minus lambda by mu. Substitute lambda and mu value. Lambda is 6, mu is 15 by 2. Therefore the calculation value 1 by 5.